So the first elasticity we're going to look at is the price elasticity of demand. So this is the first elasticity. And so what we're thinking here is how responsive is quantity demanded to changes in price, right? How responsive is quantity demanded to changes in the own price, like the price of this good? So that's the idea here. We're usually going to think about breaking, we can think about categories of elasticity. We're going to say that something's inelastic if, a 1% change in price causes a less than 1% change in quantity demanded. So we're going to think about something being inelastic if quantity demanded is not very responsive to price. We're going to call demand inelastic if quantity demanded is not very sensitive to changes in price. And we're going to call demand elastic if quantity demanded is sensitive or very sensitive to changes in price. And so let's think of a couple different graphs where we have an inelastic demand curve versus an elastic one. So maybe we can even just draw it right below. So price and quantity, and let's try to draw. This will be our supply curve just right. Try to do a 45-degree line, kind of keep it relatively similar between the two graphs. And here we're going to think about it as being inelastic, and we'll say elastic down here. And so I'm going to draw a couple demand curves here. So let's draw a really steep demand curve for this one. So again, it's going to be related to slope, but not quite slope. And then we're going to draw a relatively flat demand curve here. So we have quantity and price, quantity and price. Okay, so now let's imagine that the price in this market changes. Well, that's going to be because the supply curve shifts, right? Let's leave demand curve alone, and let's imagine this supply curve shifts. So something like that. Well, let's look at what happened in these two situations. All right. So in this situation where demand is relatively inelastic, it's not very sensitive to price. So the price went up. So here's the new price. Well, quantity did not change that much in this market. Quantity demanded, this movement along this demand curve. We didn't change our quantity demanded or our quantity too much, right? Whereas in this graph over here, we see the shift in supply curve, this change in price, causes a big change in quantity. There's a big change in quantity demanded in this flat demand curve. So the small price change causes a big change in quantity demanded. Whereas over here, this price change caused by this supply curve shift only caused a really small change in quantity demanded. We only moved a small ways between these 2 points. So if it's inelastic, the demand curve is going to be relatively steeper. When it's elastic, the demand curve is relatively flatter. But I can't underline this enough. Elasticity just isn't about the slope. Even on a straight line, an elasticity is going to change. So we need to just get a little bit more precise with a formula on how we calculate this, and then we can show how even on a straight line demand, a linear demand curve, we can get all sorts of different kinds of elasticities. So our formula for the price elasticity of demand is going to be the following. So a lot of times you see it represented, it's supposed to be an eta. It's a Greek letter. You can put N, you can put whatever you want for, as long as it's clear you're talking about elasticity. If you define that eta is elasticity, then use eta. But if you'd like it to be N, just say, this is my elasticity. So what it is the percentage change, so percentage change in quantity demanded over the percentage change in price. Now we know that because of the law of demand, these have a negative relationship between the two. But whenever you see economists express price elasticity of demand, it's always positive. So we take the absolute value of this. So it's greater than 0. And so, like I said, it's usually going to be negative because of this negative relationship, but we take the absolute value after we calculate these percentage changes. After we calculate this fraction, we take the absolute value, so it's greater than 0. So it's going to measure the buyer's sensitivities, or sensitivity, hopefully that's spelled right, looks crazy, sensitivity to changes in price. So it's measuring how quantity demanded changes from changes in price. So in terms of interpretation, say we got eta equals 3. We'll talk about how we actually calculate these, and we're going to use a certain method to calculate these percentage changes, but let's say we get the number 3 from this calculation. What this means, a 1% change in price is associated with W bar, is supposed to be with a 3% decrease in quantity demanded. And I guess this should change, and it should be maybe increase there, just to make it. A 1% increase in price is associated with a 3% decrease in quantity demanded. So that's how you'd interpret a number once you calculate this fraction and take the absolute value. But let's talk about how we calculate this fraction. In particular, we're going to use the midpoint method to calculate this. And that's because we just want the elasticity to be the same kind of both ways. If we calculate between point A and B or B and A. So let's talk about that. So it's important in this course that we all use the same method to calculate this fraction before we take the absolute value. And in particular, we're going to use the midpoint method in this course. Use midpoint method, and I'll explain what that is. Essentially, we're going to be calculating the elasticity in a midpoint between two different points. So in the middle of two different points. All right, so let's just rewrite this fraction and let's think about how we're going to calculate, let's talk about how we're going to calculate this percentage change in quantity demanded. So we can think about the quantity demanded in, let's say, we can use 1 and 0, 2 and 1, in period 2 minus the quantity demanded period 1, or 0.2 and 0.1, over the average quantity demanded. And we're going to use the same method down here. So price at 0.2 minus price at 0.1 over the average price. And so the fact that we're using the average in the denominator is what makes it the midpoint method. So let's just make that clear. So usually when you see a bar above a variable, it means it's the average of that. So here the average quantity demanded is just both of them added up, just how you'd normally calculate an average, divided by the number. Well, we just have 2 here. Same with the price. P2 plus P1 over 2. So this is what makes it the midpoint method, that we're using the average of these two numbers in the denominator and the average of these two numbers, P2 and P1, the average of those in the denominator of this denominator. So it's important that we're all using this same method. I need a bar on there. It's important that we're all using this same method, otherwise we'll get different answers. So we always are going to use the midpoint method in Econ 111 or 110 at Queens.